Now we are going to discuss about the memory technologies used in embedded system. Especially we can say mainly there are three types of memory in embedded system. One is the CPU registers. Okay, that's very important. And after that we have the flash or the code memory and the data memory. We already discussed that microcontrollers are based on Harvard architecture. So in a Harvard architecture, the program memory and data memory will be separate. Okay, so that's the reason you'll be able to see that flash memory and data memory. Okay, both are separated. And apart from that, something new you are like learning here, that is CPU registers. So keep this in mind, some data which is some data or instruction, whatever is there in the CPU registers, okay, which you can access it fastly, like the processor or the controller. Even inside the microcontroller, there will be a processor. So that processor will be able to access this data quickly. So if you have more data in the CPU registers, if you want to have more data in the CPU registers, the controller should be like that. It is having several registers. Okay, like in basic controllers and you will be able to see only limited number of registers will be there. On the other hand, in advanced controllers, you will be having so many registers, like ARM controller, the 32-bit ARM controller. You will be having so many registers, and in this registers you will be able to store more data. Okay, so ARM controller is based on load store architecture. Okay, so you'll be able to keep everything in the CPU register, so the fetching will be easy. So hence this kind of like microcontrollers will be faster in the process. Okay, so they'll be able to process data quickly. Yeah, so the microcontrollers where you are having maximum data in CPU registers, you will be able to access it quickly. So the processing speed will be higher compared to the other controllers where you are having only lesser number of registers. Lesser number of registers means only very less information will be able to store it in the registers. Only very necessary information we can store it in the registers. So hence the speed will be little bit less compared to the controller where we are having so many registers. Okay, it's not only having so many registers, and we are actually supposed to keep the necessary data or whatever we need quickly. Okay, so maybe the frequently used data we have to keep it in the registers. Okay, yeah, I think that's clear. And here we discussed already the RAM and ROM space is separate. Right, so which will be higher? Okay, so I already discussed about RAM and ROM. Now, in general, we just want to see that what's the difference between RAM and ROM. The full form, I think all are clear: random access memory and ROM. So always keep this in mind. Okay, the code actually we want to give the permission only to read for the user. So always the code will be in ROM, read only memory. Of course, then the data will be in RAM, right? So read only memory will be the permanent storage. Keep this also in mind, it's permanent storage. So that means once I return the program in the host machine, I compiled, I created the hex code. Okay, and using any cross compiler, I dump the code into the microcontroller. So I'll be dumping the code in the microcontroller ROM. Okay, so once it's done, then it's already like having the permanent storage, and nobody will be able to like alter that if it is already done. If you want, you can actually reprogram that device, no problem. It's not like that only once I will be able to program the controller. You can take it and you can reprogram. If you have some errors or if you want to add some features and all, it's you can do. But it will be once it's done, once it's like done or dumped to the controller, it will be having permanent storage over there. Okay, and usually the stored data is in gigabytes. Okay, like in controllers, usually you can see it will be in the order of megabytes and all. So this information you can get it from the data sheet of the particular controller, whatever you are using. One thing I can tell you, like in the basic controller, like 8-bit controller, like 8051 and all, you will be having like very limited program memory. Okay, so that's why I'm telling you can't write so many, like so many lines, so much complicated code you can't write for the simple 8-bit controller. But on the other hand, for 32-bit controller, you'll be having more ROM, like okay, more space in this ROM, so you'll be able to store the like more lengthier code. And yeah, on the other hand, RAM, always RAM size will be lesser than ROM. So RAM size usually will be in megabytes. Okay. And ROM is non-volatile memory and RAM is volatile memory. So RAM, we can't expect the permanent storage. So that's the reason it's called volatile. Okay. But ROM is non-volatile. And here we can see like in RAM, we can do the normal operations. That means even while the like any embedded application is running, even from the application, there is a possibility that we can generate some data, and this data we can store it in the RAM. Okay, so we can edit it like even when we are actually using this application runtime, it is possible. On the other hand, ROM, as I told, it's not possible. Once I done means once I added the code into the ROM space of the controller, it become permanent there. Okay, so usually ROM used for startup processes of computer, like especially if you are talking about the microprocessors. Okay, so the code, okay, so the code whatever you are writing for that particular operating system, so that will get stored in the read only memory, and you'll be able to read it from there. And in RAM space, accessing the RAM or writing the data to the RAM, which will be faster compared to the ROM. ROM writing data will be like writing process will be slower in ROM. Yeah, this is again a few information about the flash memory. Always keep in mind, flash memory is ROM only. Okay, ROM or non-volatile. Okay, so whatever you like, you can call. So from like now onwards, we will be discussing flash memory. Okay, so you have to imagine that flash memory is somewhere we are going to store the code. Okay, flashing, the process also known as flashing. Flash memory is a non-volatile memory and it hold our embedded application code. Okay, and some data. Why some data I would like to keep it in the ROM? Have you think about it? Have you thought it? I'm telling some amount of data, we are even storing it in ROM. Why it is required? See, for example, I'm telling the example of washing machine. Like I told already, certain data, maybe the manufacturer already set it. If I want to wash this particular type of clothes, okay, I would like to keep the timer for 50 minutes. Okay, if I'm like washing this kind of clothes, I'll be keeping this for 1 hour. So this already manufacturer decide. Okay, maybe they have done so many surveys and testings and all, then they already finalize this is the time duration for different type of clothes. And if this is 50 minutes, okay, this much time you have to do the rinsing or washing, or this much time you have to do like any other processes. Okay, so what are the other processes you are using? So you will be dividing each and everything for 10 minutes or 5 minutes or 15 minutes, whatever it is. So the manufactured or like manufacturer already designed or they already decided. Okay, so this kind of data which is permanent, which they will be writing with the code itself. Okay, so this kind of permanent data others shouldn't be, means the user shouldn't alter. So that's the reason they will be keeping even this kind of little bit data, not too much. Okay, little bit data which is necessary, they will be keeping it in the flash memory. Yeah, now we are talking about the RAM. RAM we discussed already, random access memory, which is dedicated for storing the data. Okay, so maybe like especially like I would like to say about in program, in the embedded program, you know about global variables and all, right? Global variable, program stack and heap sections. So this all will be stored in RAM. Okay, RAM memories in the microcontroller usually will be lesser size compared to the program memory. And of course, RAM memory is costlier than the ROM memory. That is also one reason RAM always will keep it like in lesser size compared to the ROM. So in RAM, what kind of data I'll be storing? For example, I already told about the stack. Okay. So what a stack here, stack and heap. We'll discuss that. Okay. One example I will tell you. Once I was in the washing process, like the machine is on and we kept a timer for 50 minutes. Okay. And maybe in between, like we got the interruption in the power supply, the power is gone. So I already done the washing till 30 minutes. Okay. Then maybe the power is coming after 10 minutes. Okay, so it shouldn't start washing from like at the beginning, right? Okay, if you are doing like that, okay, you will be losing the quality of your clothes and all. So I have to resume the process only from 30th minute. That means 30 minutes already done. Maybe if I can start from the 30th minute or 31st minute. Okay, so this data temporarily I want to store, not permanently. Okay, temporarily. Only in that occasion it happened like that, right? So this kind of temporary data, even I can store it in RAM. Okay, I think that's clear. And one more thing I would like to discuss here about the CPU register. CPU register is also volatile. CPU registers hold operands, instructions, addresses. Okay, so all this information will be like holded in CPU register. Runtime state of the program. So that will be there in the CPU registers. CPU registers in general registers we can classify as general purpose registers and special purpose registers. Okay, general purpose registers in the sense we can store any like general information. So special purpose registers means the manufacturer of the particular controller, they already designed or they already decided that this kind of information you have to store it in this particular like register. Example, I will tell stack pointer. Okay, so many things are there. So that stack pointer is used to will be giving okay where the stack is pointing, where the stack top is pointing. Similarly, program counter. Program counter is a special purpose register. So in that like a program counter, it will be holding the address of the next instruction to be executed. So we are getting the complete flow. Okay. So this kind of special purpose registers are there. There we can't store any general value. So general registers will be there where we can store some data general. Temporarily, if you want to store some data, we can keep it in the general purpose registers. Okay, and I already told you about different controller. Okay, they will be having different number of registers. So the basic controllers and all, they will be having very limited registers. Advanced controllers will be having more number of CPU registers. And if you have the data in CPU, the fetching. Okay, so the accessing for that data will be easier. So that's why the controller can do some operations quickly.